So it's 2010, and I'm riding home on the bus with a couple of my colleagues from Opscode. And we're discussing a project that I'm planning to build in my backyard that weekend. And I've got my notebook out, and we're discussing how I should join the corners of this thing we're building, whether we should use bolts and corner block or screws or nails. Conversations going on, we're kind of nerding out on it. Time for our stop to get off, and there's a passenger that was sitting next to us who kind of gets up the courage to admit that he was eavesdropping on us this whole time, and is like, "Excuse me, but I've got to ask, what are you guys building? It sounds really interesting and complicated." To which the answer was a sandbox for my son in my backyard. So a sandbox, right? 4 sides, no bottom, no top. Put some sand in it. Doesn't really get any simpler than that. But as I said, I'm not much of a handy person, and I realized that there's a lot of questions that I had to answer. What type of wood should I use? I live in Seattle. It's rainy there. I don't want it to rot out right away. Screws or nails? How should I join the corners? I'm not really sure. Should I use bolts or whatnot? How much sand do I need? So each simple feature is attached to complexity. It's like there's this special kind of unbreakable thread that is connected to any given feature to this complexity that it drags along into your system. And I needed almost 2,000 pounds of sand to fill this little sandbox, which didn't look like much in the sandbox, but when I went to the store to purchase that much sand, it looked like a lot. So this is the story of Pooler, which is an exclusive access connection pooling library that I wrote, and its journey as a simple project that got more complicated as it went along. But what it really is a chance for me to share some of the secrets that I uncovered for building robust OTP applications. So kind of the heart of my discovery I'm about to reveal, and after this, you know, if you want to leave, I suppose you could. You'll probably have gotten like the main core of the point. I'll just cry later. So as I'm building these features, the realization I had was that thinking about the supervision tree of your application as kind of a first-class concept for adding features, for working on the design, is a really useful construct and was really helpful for me. So supervisor-driven design. It also turns out to be a really useful way to understand code that you're not familiar with. So if you get an Erlang application that you haven't seen before, if you can visualize the supervision tree, that can be a good way to understand what it does, how it behaves under certain kinds of failure conditions, and so on. So if you haven't already, you should start here and read these books. They're all really useful in their own ways. But the thing is that until you go to build your own system or your own sort of larger application, it's hard to come across some of the tricks, even if they're hidden in these books and live there. Because as you're learning, for example, you really can't, as you're learning, focus on the supervisors first, because there's too many other things to worry about. So my claim is that you aren't using enough supervisors and that you aren't using them as effectively as you can. And so I'm going to be telling you kind of some of the ways that I did this, and some tricks of the trade kind of stuff that I picked up. These aren't my inventions, certainly, but things that I've learned going along and seem to be working. And all of that said, I certainly expect to learn something here, and feedback is welcome. Kind of hoping that it's not, hey, did you realize you could do all of that with gproc and 10 lines of code? But if that's the case, then let me know that too. OK, so once upon a time, it was in September of 2010, at Opscode, we were experimenting with Riak as a backend data store. And as such, we needed a connection pool to pool the Riak protocol buffer clients. And so I started in writing pooler. Didn't need it to do a whole lot, right? I needed exclusive access to the pool members, so we had to maintain a pool of members and track which ones are in use and which ones are free. And this is a relatively simple thing to do. Simple. And Erlang gives you great primitives for doing this sort of task. But then you realize that there's a few more features that you need. If the consumer crashes, that's the guy who takes a member out of the pool, you don't want to leak that resource. You want to return the member to the pool. And if a pool member crashes, well, you better create a new member to put in the pool. Otherwise, your pool will drain over time. I wanted to have a notion of multiple pools, at least for this initial inspiration of pooling Riak clients. I was thinking about how I was going to have multiple nodes of the database, and I was thinking I would have a pool of connections for each one, and then do some naive load balancing there. There's yet more features you could imagine wanting. So you might decide that you want to grow the pool dynamically and be able to add new members asynchronously and not block the pool while you're adding members. You might also want to do that in parallel, especially in some use cases, as I'll talk about some. Once you do that, and doing that asynchronously, you want to think about a timeout so that if you go to start a member and it never comes back, you kind of want to deal with that case. I decided it might make sense to have an initial pool size and then be able to grow the pool to handle a burst of capacity. But then once you've done that, you want to think about, well, maybe you want to reclaim your resources after the traffic subsides. And so then you need a mechanism to cull members from the pool that haven't been used in a while. So all of that adds little features, none of them kind of earth-shatteringly difficult, but the thing sort of grew in complexity as it went. So here's the story of how it went. Some of the first part is kind of for illustration purposes, but there you go. So kind of imagine version 0 as not something that we actually used, but just kind of a first attempt was you've got a pool supervisor, pooler supervisor, pooler soup at the top level, and a simple gen server pooler that contains the state for which members of the pool are in use and which are free, and you talk to this gen server to check out a member and check in a member. The pooler gen server is going to call some MFA start link for starting the member, so it can pool any sort of thing. And that was an important thing that I wanted to have happen as part of the design of Pooler, is to be able to pool any kind of generic OTP application. Just to kind of illustrate the flow, just in case, I don't know, just so it's clear, so you've got Pooler as the gen server, and you've got a consumer that comes along and sends a message to it saying, hey, can I have a member? And Pooler creates assuming it has a free member, it's going to create a link to that process and then send back a PID of the member. And then the consumer is going to do some work, talk to a database over this connection, and then return it. And at that point, Pooler frees it up and breaks the link with the consumer. What's the problem? What's sort of the thing that's missing at this point? It's that we're not supervising these members. The gen server Pooler is starting them directly. And unsupervised children in your OTP applications is something that you should try and avoid if you can. So that was kind of a rule to come across. Like, let's try and not have any unsupervised processes. Sounds good. So why? You want to know you want to be able to find all of your processes that are in the system, and you want to be able to know where they came from. And when you have processes that you're just spawning off willy-nilly, even if you think, oh, it's not so bad, they won't be long-lived, and how do you know that they won't be long-lived? You can get into situations where if you have this kind of process and it hangs around, that can consume memory and over time grow and be hard to detect. And then finally, the squid will come after you if you have too many unsupervised processes. OK, so we add a supervisor. Doing this kind of thing, straightforward. Member soup here is a simple one-for-one supervisor, which is a good pattern to use when you want to supervise a collection of things that all look the same. And that's great. That gets us that rule 1. Just a couple of kind of details because that'll help sort of as we progress. So the member soup, so he's supervising the pool of members, and the kind of important piece there is that you pass into him through the init args the MFA that describes the type of pool that you're the type of member that you're starting, and so that sort of information about the thing that you're pooling is encoded in the supervisor. And then inside pooler, when you want to start a new member, add a member to the pool, pooler calls supervisor start child and talks to that member supervisor, and that creates a member, and that's great. And then kind of the last thing of making that transformation happen is wiring the member soup into the supervision tree of this pooler application. And so that's what you're seeing here, static child spec. Here's the member soup spec, and that just gets wired in, and so then that's where you get that arrow at the top. Generalizing this in terms of something that might be useful for you to apply to your own applications is that when you're looking through your code and you see places where you're calling start link or especially spawn or spawn link, that could be an opportunity where you could add a simple one-for-one supervisor and then replace those calls with a call to supervisor start child. Cool, OK. We could do that. So that still didn't kind of satisfy our initial feature set, which among other things, was to have some support for multiple pools. And so the member MFA is encoded in that member supervisor there. So one way that we could achieve multiple pools is by having multiple member supervisors, one for each type of member type of pool that we want to have. And one way that we could get those multiple member supervisors is to create such supervisors dynamically. So we can kind of apply the same trick that I just talked about, if you could call it even a trick, to create the supervisors dynamically. So just as you can create worker processes, it works just as well to create supervisors in this simple one-for-one pattern. And so then you end up with the supervision tree that looks like this, where there's now a new supervisor that supervises this new set of things that we've introduced, so pool soup. And pool soup supervises the member supervisors. And everybody is supervised. And we've satisfied that rule. Just to kind of to illustrate sort of the message flow, what happens, so we're all on the same page. So pooler, during its initialization phase, is going to read its config and know that it needs to start a pool of a certain type. So it's going to call start child message over to the pool soup there. And then he's going to call start to create a member supervisor. And that whole process sort of results in the PID of the member soup coming back to pooler. And now pooler has that PID of the member soup and can call new member on that member soup. The member soup creates a member, sends back the PID, and we store it, and life goes on, and that's great. Cool. So that sort of represented the first iteration on pooler. I mean, it really started as kind of this small, like do the simplest thing that would work kind of a project. And in part, to be honest, it was a project that I undertook so that I could have a chance to kind of build a complete OTP application from the ground up myself and kind of have that. And it was a great exercise for that. So we had multiple pools, everything supervised. I added in support so that you could specify in the config an initial count of members and a maximum count. And it does a very simple thing, which is that everything's in this gen server loop. So as you're going, if the pool is full at its init count, say init is 10 members initially and max is 20, and then you ask for the 11th member, it starts the 11th member in line with the request, returns the PID, and kind of keeps track of it. I added with a simple timer that goes and records. Basically, you record when members are returned, you record a timestamp, and so then it's easy to have a timer process go through and fire and identify members that haven't been used in a certain timeout range that's configurable, and those get cleaned, but you maintain the pool such that it's always at least init count size. So I did all of this work, and then we actually decided to move in a different direction at Opscode in terms of the backend data store. As you may have heard, Opscode Chef, the server, we rewrote it from Ruby into Erlang, and then the backend data store is now Postgres. So time passes, dream sequence. It's now 2012. And the team at Opscode got some really great and exciting news, which was that Facebook was going to become a customer for us. That good news kind of came with some bad news as well. So we had this work in progress port of the server, the Chef server API, to Erlang and talking to a SQL database, and it was very far along, but it wasn't shipped yet, and we needed to ship it really quickly. So at the time, we actually were using a different connection pooling library that is also a good choice called Poolboy. And when we were load testing our stuff, we ran into a hang with the Poolboy library where we could tell it had members in it, but it was locked up and confused, and it would just hang. It turned out, I think, two weeks or so later that the folks at Basho were doing some of their quick check learning stuff and put Poolboy under quick check and identified, I believe, this bug and perhaps some others and subsequently fixed them. But we were under a time constraint, and I had this library, and so I said, hey, let's give this a shot. And that worked pretty well. It didn't have that same problem, partly because Pooler took a simpler approach to the behavior when the pool is full. It just returns an error message and says, hey, I'm full. If you can check back later. And whereas what Poolboy does is it maintains a queue and gives that request the next available in sort of a first in, first out fashion, which could be a good feature and is useful, but we didn't need it for our use case. But what we did notice as we were testing it is that occasionally the whole system wouldn't start up. Yeah, so we had to fix that. The problem was that Pooler we were pooling at that time eMySQL connections, and Pooler would be starting up and trying to start them, but the eMySQL application itself hadn't been started. And the issue was one of sort of a lack of formal dependencies. So since Pooler doesn't know anything about the members that it's pooling, it doesn't depend on them. And so then there's nothing in the system that was specifying, hey, like, the eMySQL application better get started before Pooler starts and tries to start those members. So we had to find a way of fixing that. And that led to a discovery of a not often used feature of the OTP systems called included applications. So if you haven't seen these before, it's a fairly simple idea. And that's pretty fun because on the slides for me, there's white and gray. And I'm thinking that's pretty much white and white, huh? Yep. Yeah. OK, that's cool. So on the left, two applications. So these are two supervision trees of two separate OTP applications. And I think, fortunately, the shapes are different enough that you guys can probably solve this puzzle. But what's happening then on the right is that we've included this guy into this application. And so what that means when you do that is that you're responsible for starting the top-level supervisor of the application you're including. And among other things, that gives you some nice control over the startup ordering. So anything that you then depend on is going to be started before you start, and then you start this other thing that maybe doesn't have dependencies. Wiring this up, just to kind of illustrate how that goes, in your application, instead of listing, say, pooler in the application list, you list it in the included application list. And then you wire it into your supervision tree somewhere. So you wire pooler's top-level supervisor into your supervision tree. In Pooler, didn't really need any changes to be used as an included application, but it was an opportunity to learn a little detail about pulling things out of your application environment with application getenv. So there are two arities of this function, at least. An arity 1 where you just specify the key and the name of the application is inferred as the currently active application. And then an arity 2 form, which is explicit, where you specify an application name and a key for the config. And initially, I had used the arity 1 version. And the problem with that is that when you're used as an included application, the active application is that guy that included you. And so Pooler couldn't find its config. And so it was a one-line change, and I moved on. But it sort of drove home that more explicit form, I think, is really the way to go pretty much always. One, it lets you do stuff with included applications, but also it makes sure that your configuration is always namespaced. I mean, sure, you could sort of inject config for one app into config for another, but I don't see any benefit to that, whereas if you keep them separate, everything is always namespaced, and you don't have to worry about configuration keys conflicting and so on. As we load tested it, there are a couple of points that I think are worth kind of chatting about. The first thing was that I had decided to make the return member call, to make ReturnMember, that part of the API, cast in the Gen server, because I was thinking somewhat naively like, oh, well, I don't, as a consumer of a member of the pool, when I'm returning it, like, I'm done, and I don't need to wait around, and I don't really care about the pool. Who cares? So I'm just going to make that a cast, and that'll make everything go faster. That's not a good way to make things go faster. We saw some problems under load, and we got easier to reason about behavior and more regular behavior by changing that return member call into a call instead of a cast. And sort of the key takeaway point is that by making a synchronous call, you're feeding some back pressure throughout your system, and that overall gives you a more stable thing to go. And so I would say that the time to use cast is when you need the asynchronicity to avoid a deadlock. Say you're trying to send a message to yourself or something like that. More really for the structure of the asynchronicity, and that you should sort of, if you're in doubt and you don't need that, you should use call. And if you have performance problems, you should measure. And if you're too slow, you probably should redesign something else rather than trying to go faster by casting, because while that will make the guy sending faster, it's very easy to then overwhelm the mailbox of the receiver, and bad things happen. So the other kind of performance-related thing we learned had to do with timeouts. And what we saw with Pooler was that if under certain error conditions, if starting members got slow enough, and these were happening inline, such that they exceeded the Gen server default timeout, that the system's under load, it's starting to slow down, and then all of a sudden we just fall off this cliff where everyone crashes, everything in the pool is crashing, the pool ends up getting torn down, and you try and recreate it, but you're already under load, and so things are already slow, and it kind of forms this death spiral where it's really hard for the system to recover. And while I was kind of hesitant initially to consider setting infinity for the timeout, because I was like, well, then it's just going to hang forever, it turned out that in some cases this is a useful strategy where the system is still going to degrade and perhaps still fall over, but it does so in a way that is a little more graceful because you may still be able to make progress, and maybe some of the time you're able to get through some kind of traffic burst and get past it. And at least it also gives you a little bit more time to sort of understand the system and maybe see where things are really going wrong, whereas with everything crashing all at once, it's so noisy, it's a little bit hard to know what's happening, at least initially. OK, so almost time to ride off into the sunset. So some more time passes. It's 2013. We're using Pooler in production. It turns out that we're now actually using it to pool connections to Postgres rather than a different database. And we got some great help testing and validating our system as a whole from our friends at Facebook. But given that the way that we're using Pooler is actually very different than what motivated the initial version to be written, there are some things about it that are kind of lacking. So I want to run through a couple of those and talk about some of the work that I've done over the past couple of months, taking a stab at improving the architecture of Pooler and making it better. And this is code that hasn't been yet tagged to a release, but is now on master, and you can go check it out and give it a try. So the first thing that I wasn't so happy about is that I had a single gen server serving all pools. This could be a problem in terms of a bottleneck, but more importantly, I'd like to be able to use Pooler to pool different types of things. So I'd like to be able to pool Redis database connections alongside Postgres database connections. Or maybe I'd like to pool connections to 2 different independent Postgres database servers. And I don't want those to be related in terms of the failure domain. So coming back to the idea of thinking about the supervision tree, I don't want it to be the case that if one of those services on the back end starts having problems or falls over, that those crashes cause the pool for an unrelated database server to become unavailable or slow down. I wanted to be able to dynamically add pools. That seemed like a better way to go. I had tried very hard for, I'm not really sure why, I think just to try and keep Pooler as simple as possible, to have the pool config be something that you specify in app config and kind of leave it at that. And I think it was time to add that feature. Even with breaking out into multiple gen servers, the strategy for how members are added is in the present version that we're coming from, is synchronous and in line with the gen server. And so that's fine if the startup doesn't take too long, but if you start getting into a case where the member startup time takes any appreciable time, or if you want to be able to dynamically add capacity to the pool and do so in, say, batches, where you'd like to be able to add 10 new members, then you don't want this. You don't want to do that synchronously and block the access to the pool while you're doing that. So that leaves us with two items to tackle here. Give it true multi-pool support, and make it so that we can add members asynchronously, and we'll also do it in parallel. So I come to the supervision tree. So this is where we're coming from. And kind of based on what we've talked about in terms of wanting to have multiple pools, what you can kind of visualize is that this whole, you kind of want this whole, you want a bunch of copies of that thing, in a sense. This is the supervision tree that I ended up with. So each pool has a kind of a supervisor at the top level that supervises a pool-specific gen server, and then also supervises a pool-specific member supervisor. And then there's also this starter supervisor hanging off to the side there, which I'll get to, but that gets used for starting members asynchronously. In terms of implementing this, another little way that you can create supervisors dynamically. So this is dynamic supervisors take 2. So instead of doing the simple one-for-one trick, another thing that you can do is you can create the child spec that you normally would see kind of hard-coded in your supervisor module. You can create that whenever you want and then pass that to supervisor start child. So not difficult at all. There was a point where I just didn't, I guess, quite realize that that was a thing you could do and that it was easy. So I made these, the supervisors are registered, and that gives them nice named processes. For the sizes of and numbers of pools, I'm thinking that's going to be reasonable, but I'd be interested on feedback if someone thinks that's a really bad idea. And so you can have a function that takes the config pool name and munges the name to give you the atom pool name that you want to register with, and so pool soup name, pool 1, and pool 2 result in these 2 pool names. And then we can have a function new pool and a helper function to define the supervisor spec that calls then that dynamic name generation. So really super easy and not deep magic at all, but kind of it's good to know if you don't, that you can create supervisors in this way dynamically as well. So with that, we have, yay, multiple pool support. So that was a big increment of feature, and I think it was made a lot easier, and the direction was a lot easier to find by focusing on what I wanted the supervision tree to look like, rather than it sort of getting too down in the weeds on some of the implementation of the feature, if you will. OK, so async start. So what's currently happening in the gen server is we're calling supervisor start child of the pool member supervisor, and that's going to block until the member is started. And so if we want that to be asynchronous, the solution, as is often the case in Erlang, is to put that work off into a separate process. So I thought about having so that process is, I termed so creatively, a starter, and it's a little very thin worker gen server. Pooler sends it a start member message, and it returns immediately with a reference saying like, cool, I got your message, and then goes off and tries, talks to the member supervisor to start a member, and that takes however long it takes, and when it comes back, it then sends the PID of the member that got started back along with the reference so it can be identified, and that reference also makes it just makes it easy to track which is coming from which, and to set up a timeout so that if you kind of clear out the starting members if a given member takes too long to start, and then if you receive such a message later, you can ignore it. Kind of a refinement of that overall picture, though, was to introduce yet another supervisor. See, I told you, it's like all about supervisors, right? So starter soup is a simple one-for-one supervisor for these starter guys. And what I wanted is that I wanted to give the starter gen server everything it needed to do its job when it was started in its init, and that it would kind of wake up, do its work, and then exit cleanly and be done and be a short-lived thing. So that's how that works. And that takes advantage of another little subtlety in the gen server API that if you don't know about, you should, which is that all of the gen server callback functions that you implement, one of the ways that you can return is to set a timeout value as an additional argument in the tuple that you return, and you can also do that from init. So if you add a timeout, then if you don't receive any messages, that server doesn't receive any messages when that timer has expired, the gen server is sent a timeout message that it can then take some action on. And in particular, you can set that timeout value to 0 in init, and then when the process starts, it immediately gets a timeout message in its mailbox, which it can then take action on. And so this is a way of kind of triggering this one-off, short-lived worker process. So that's a nice thing to know about. Just one more time with all of the members in play, right? So pooler sends a message to the starter soup. Starter soup starts a starter and then sends a reference back to pooler. And then meanwhile, the starter talks to the member supervisor who starts a member, and time passes, and the message comes all the way back then to pooler, and then poof, the starter guy exits. Cool. So, so we're like 98% done. So we did the multiple pools, which was fun, and now we've got async and parallel start, but we only have it once we're running because this message that's coming back to pooler to accept the message is a gen server call. So in order to kind of do this messaging and have the asynchronous stuff working, pooler has to be running and live. That works fine for dealing with, like if a member crashes and you need to replace it, that's cool because now we can add back that member in an asynchronous way, and we can also do the dynamic adding of capacity in an asynchronous way. So we can add a batch of new members, which is cool. But what we can't do is at startup, if we want to parallelize the start of members, we don't have a way of doing that because while we're in init, we can't receive messages. And if we started before we had pool members available, then people could ask us for things, and the system would be sort of pretending to be available and live, except we wouldn't have the members, and then errors would happen, and we'd be sad. OK, so I kind of struggled with this one. And so I kind of ended up using a pattern that I imagine a lot of you have seen before, and said, OK, well, I'll just use spawn and a function that gathers the PID. So I'll go in my init, I'll spawn a bunch of calls to start members, and then I'll await them all to finish. And well, at least it isn't very much code to do that. So so that's good, right? And so I thought I was done. But then I was thinking about coming and giving you this talk and talking about how all children are supposed to be supervised, and then you would look in the code and see that I hadn't supervised all of the processes, and that just wasn't going to fly. So I took an attempt at sort of fixing this, and it led to all sorts of complexity, and I really hated it and had to throw it out. And so I came back to, well, I mean, it's just an init, like maybe just once, that'll be OK, and it's really not for very long. Yeah, and then I realized, no, I really had to fix this properly. So kind of coming back to how the asynchronous stuff works, I was thinking about, well, so what I want to have happen is it's like I want to send n start messages and then somehow have a way of waiting for n replies. But then, again, just to reiterate, this can't work because in order to receive the replies, I have to be running. And so I want all of this to happen during the init phase when the pooler gen server is inside init. And so that led to me going and reading the source code for gen server and that stack of things, which is a really great resource, incidentally, to go and just dig in. And when you have a question like, well, I wonder, am I allowed to do such and such? You can go and look in the code and with a little puzzling, probably determine if you can do such and such. So it turns out that in init, nobody knows your name. And your server loop hasn't been started. And so that's a reasonable place to do some raw message sending and receiving. So that's how I solved the kind of parallel start issue for pooler, is that in init, it's set up so that that member soup has an alternate start function where you can pass it, instead of using the kind of gen server mechanism for the reply, you can pass it a PID explicitly and use raw messaging to send the accept message. And so that gets us this picture. And that seems to work, and I thought that was kind of a fun thing to learn about, because sometimes in a gen server you have more complicated work to do where you'd like to do interprocess stuff to make it happen, and you don't want to become available and sort of start your loop before you're done, and so this is one way to achieve that. So with that, we've got the multipole support. We've got everyone supervised. We've got the dynamic pool size. I've got it set up so that it adds batches of pool members in parallel. You can do dynamic pool creation now, and that actually provides a kind of a easier, in the end, solution to the included application and startup ordering thing. If instead, basically, once you have the ability to just create a pool on demand, then you can start the pooler application with nothing, and whatever point in your application code can then add pools as you go. And I think that's really the better model, because what I'd like to see happen is I'd like to make pooler kind of a background. You start it up, and then different things can use it. They don't, multiple different apps could use the same pooler instance to pool different things, for example, with this model. So codes on master, kind of overall takeaways, and think about the supervisors and what the tree looks like and how you want the failures to work, and think about that shape as a way of driving your design. I think that's really useful. Make sure everybody's supervised. I think it's useful for technical reasons, but I think it's also useful in that it helps drive your design to something that is cleaner and easier to reason about. You can use the zero timeout trick in init to make worker things happen. You can send raw messages in init to do more complicated work. And that's it. So thanks.
So we have 7 or 8 minutes for questions. Are there any questions for Seth?
How long did it take you to figure out how to use step servers and stuff like that? I'm kind of in the middle of this experience myself right now.
Yeah. As I was learning, I followed some of the different books that were available and did some of the examples and those sorts of things. And I think
Did you do that concurrently with writing your code, or did you write the code with low-level message passing first and then
well, this wasn't like the first gen server stuff that I had written, so that maybe doesn't serve as a good example. But I guess I would say that I kind of learned sample projects where I did some of the raw stuff. I mean, that's useful to understand and to go through. But at the point that you're ready to build a thing that you're going to use, I would say to jump right into the gen server stuff straight away. And then if that's sort of still at the point of too much, I would keep hacking on some smaller things, perhaps. Any other questions? Does anyone here use Pooler? No? That's cool. That's OK. Oh, yeah, well, my colleagues. Cool. Well, thanks very much for coming.